My talk today is the tale of three knowledge graphs. So imagine you're asked to review this paper. And I imagine many of you as academics often have this problem where you're either serving as a reviewer for a conference or a journal, or your advisor says, hey, I need some help with this paper, can you review it? So today I'm going to talk about these sorts of problems that require lots and lots of knowledge to make complex decisions. And I'm going to motivate this through three knowledge graphs. The first is going to tackle scientific reproducibility, which is motivated by that first setting. I'll talk about competition in business and about how a struggling entrepreneur can use knowledge to get a leg up on the competition when creating a business. And the last knowledge graph will be common sense. So the sorts of ideas you and I may take for granted, but AI models are still trying to wrap their heads around. We start out with papers and the claims they make. So what is it that the paper is trying to show? What is the argument that it's making? And we first look at things at the micro level. We try to look at all the details about the study, the sample size, the sample population, the different trials that may be undertaken, the models used, the p-values of those models, the effect sizes, etc. The goal is actually to take something that a user supplies us, like a label for a particular token, and look at all of the sensitivity of that label in kind of a semantic parse of the sentence, and then identify these trigger phrases. And together, we can take the user labels and the trigger phrases to identify new instances of, for example, people. And I'll show at the end of the talk a place where, or a tool that's been developed using this approach to label data for knowledge graphs. So on to the next of our three knowledge graphs. This knowledge graph is about competition in business. So we take data from web pages, patents, spreadsheets, social media, and regulatory filings, and we put it all together and run it through a set of knowledge services, which extract information, map to a domain ontology, resolve entities, and use representation learning to generate high-dimensional vector embeddings. You can see that we are able to do a better job at predicting profits with a lower monopoly rate using the noisy web data. And similarly, we can do a better job of predicting the NAICS codes using this really noisy data. This is only for the public firms, so the same firms that are covered by the SEC. And those are the firms that have the most data. So we put together this entrepreneurship portal where somebody can describe their business idea and get analysis about who their likely competitors are. And they can click on these and use the competitors, use that link to go to the knowledge graph. And so here I say my new company will build solar panels using recycled soda bottles and offer them to low-income customers. And you can see that it comes up with a set of other companies that might have similar business models. And then you could click through and learn more about them or see the links there. So finally, I'm going to talk about this common sense knowledge graph. On stage, a woman takes a seat at the piano. She, and now you have to pick the right answer. Is it sits on a bench as her sister plays with the doll, smiles with someone as the music plays, is in the crowd watching the dancers, and nervously sets her fingers on the keys? And the reason this question is hard is that there are kind of aspects here that make sense with this prompt. So pianos have benches, so sitting on a bench might make sense. Pianos play music, so we want to understand that might make sense if there's this overlap. So to take this question and understand it, we wanted to look at all of the different resources for common sense knowledge. So for example, there's a common sense knowledge graph called Conceptnet, and Conceptnet captures knowledge about pianos. For example, pianos have keys and they're used for playing music. Models like Atomic give us information about prerequisites and cause-effect results. So for example, to play a piano, first you need to sit at the piano, you need to be on a stage, and you need to reach for the keys. When you perform on a piano, you might feel engaged and competent, but you might, calm, happy, satisfied. So you can have a range of feelings from playing the piano. as you see, nervously is not here, but you can see that it has a lot of different feelings that might come from playing the piano. And all three of these knowledge graphs are supporting these very difficult knowledge-intensive tasks. So the ability to do well on predicting paper scores, predicting business competitors, and having a response generation model that humans prefer to kind of the ground truth. Those are all great strides made through the use of knowledge graphs that we've developed as part of our project.